All right, this is Unit 4, Lesson 1, Investigation 1, talking about correlation. Okay. As always, if you have questions, please ask them loudly. Okay. We just kind of did an activity where you guys ranked your music choices, and hopefully we developed a little bit of understanding of what correlation is. The book's definition of correlation, and I have changed it a little bit. I'll paraphrase a little bit. Correlation is a mutual relationship or connection between variables. Okay. So for your guys' music rankings, it was your rankings of the type of music. I was one being your favorite and I being your least favorite. All right, so that's how your rankings between you and your partner developed. There was a relationship there. If you guys agreed on the types of music, then your rankings were close to each other. If you guys disagreed, then your rankings were far apart. And if there wasn't really a relationship, then your rankings were all over the place. And hopefully we saw that. Okay. Now the second thing we calculated was the correlation coefficient. Correlation coefficient is the R value. Okay. Okay. It's the R value. And remember, a coefficient is a number. Okay. But the correlation coefficient, which is what this is a number value for correlation. Basically gives us a numerical representation for correlation. Like how this is written. So the correlation coefficient, or R, gives us a numerical representation of the correlation. It's kind of hard just to look at a scatter plot and say this R value is 3, or 0.3, sorry. Or this R value is 0.5. Right, because you guys tried doing that. Remember we tried to rank them based on how they looked? You guys remember ranking your scatter plots based on how they looked? Were they in that same order when we ordered them back there? No. Once you ordered them by their R values, the order changed. Because a lot of times when we rank them based on how they look, we're looking at things that kind of make lines where we kind of section off and only take parts of the data. But the correlation coefficient looks at every possible point of the data. So I remember when we were talking about the scatter plots, someone would say, well, those 3 points at the top make a line, but everything else is kind of all over the place. Right now, some of the ways you guys rank your or organize your scatter plots. But the correlation coefficient looks at every single point and how it relates to every other one. All right. Now, there's kind of a continuum of these correlation coefficients. The minimum value is -1. The maximum value is 1. Right in the middle is 0. Now, how many of you guys have been to like Buffalo Wild Wings before? You guys been there before? Or any other place that serves like, wings or salsa or whatever it is, different sauces that have different hotness. You guys ever been to a place like that before? Yeah. Now they give you a list of all the different sauces or flavors or whatever, and at one end they have the hottest, and the other end they have the mildest, and there's always that one that's right in the middle. Okay, you can think about it this way. The 0 is like that medium sauce at Buffalo Wild Wings. Okay. +1 would be like the hottest one. -1 would be like the mildest one. Right. Now all along from 0 to 1 or 0 to -1, there's sauces that are kind of in the middle, right? Right. There's like the medium hot, or the medium hot, right? Or the hot, right? Okay. Same thing with like a hot sauce you can buy. Like tourist locations usually have hot sauces you can buy where they have like the long list of here's the weakest hot sauce, here's the worst hot sauce. You guys know what I'm talking about or no? Yeah, okay, maybe I go to weird places, I don't know. Alright. Yeah. But either way, there's always a list of here's the hottest, here's the mildest, and you just gotta pick one along the way, right? We've all been there before. So the same thing is true with correlation coefficients. Alright? We have a strong positive correlation and a strong negative correlation. Those are the extremes. Now, every scatter plot that we'll look at will fall somewhere between a strong positive correlation and a strong negative correlation. Now, where exactly it'll fall is kind of hard to tell. And that's what the R value helps us with. It tells us, okay, this one is an R value of 0.8. That's close to strong, but it's not the strongest. Right? Or an R value of like 0.1. It's close to weak, but it's not the weakest it could be. Right? So hopefully that analogy makes sense. So here's our continuum of correlation strength. Now, if we are at a strong correlation of 1, okay, remember that data set that had a correlation of 1, or close to 1. Here's our best one. It was Alyssa and Sandra. All right, correlation of 0.816, right? What do you notice about this graph? It's kind of a straight line, right? Right? Positive slope, right? So the strong correlation, we had a positive slope. What else? When we talk about their rankings, do they generally agree or disagree? They generally agree, right? So as Sandra's X value increases, right? As Sandra, she's on the X-axis. As the X value increases, right? As her rankings increased, Alyssa's rankings did what? Increased. So as Sandra's X went up, Alyssa's Y went up, right? So if this wasn't music rankings, if it was like ice cream consumption in the temperature outside, because generally when the temperature goes up, we eat more or less ice cream. More. As the temperature goes up, we eat more ice cream, don't we? Yeah, ice cream shops open up. People just generally eat more ice cream, right? So, Long's going to disagree with me. Okay. So, it doesn't always have to be music rankings. It can be different statistics. Or minutes played and points scored, right? If you're a basketball player, if you play more minutes, you're probably going to score more points. Just how the game works, right? So, as X increases, what happens to Y? Increases. Right? Now, X and Y are just general names for variables. Okay, it can really be any variable. Now, if we go on the other end of the spectrum, okay, so here we have Faith and Jessica's. Here we see them. What do you guys notice about the slope here? It's a negative slope, right? The slope starts here and goes down. It's a negative slope. So if we have a strong negative relationship, then we see a... What's the question? A straight line, that'd be the perfect positive slope. That'd actually be an R value of 1. We didn't have anybody on a straight line. But if you agreed on every single one, so if your 1 was her 1, and your 2 was her 2, and her 3 was your 3, right? Then you would have an exact straight line. Go through 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and so on, right? That'd actually be an R value that is 1. Okay? And just like if you had the opposite of that, so you had 1, 9, 2, 8, 3, 6, or 3, 7, 4, 6, and so on, then you actually have a perfect negative slope. Okay? Or perfect negative correlation, not slope. Perfect negative correlation. Right? All right. Good question. Okay. So this one has a negative slope, right? Now these people agree or disagree on their music choices. They disagree. And if we look, as Jessica's rankings, she's on the X. As her rankings increase, right? What happens to Faith? What happens to Faith's rankings? I can't talk. What happens to Faith's rankings?
What happens?
As Jessica's increases, what happens to Faith's rankings? It decrease. Okay. So if I have a strong negative relationship, that means that as X goes up, what happens to Y? It goes down. Does that make sense? Does that make sense, guys? Yeah. Okay. And then all along the way, we have different rankings where, like this one's kind of closer to 0 because we have that Latin one up there that they didn't want to color. All right. That one's kind of close to 0 as we go through. This one's real close to 0 because the points are kind of all over the place, right? So if I'm at 1 or negative 1, those points are closer to a line. As I get closer to 0, what happens to my line? What happens to my points? Do they stay in a line or do they spread out? They spread out and they scatter, right? All right, so we're going to take a look at some made up scatter plots as we go through here. All right, we're going to look at the extremes of these correlation relationships. We're going to look at what a strong positive will look like. We're going to look at what a strong negative will look like. We're going to look at what a weak will look like, or no association. All right, so the first we're going to take a look at is a strong positive association. Strong positive association or correlation. Now, long in China, this is what you guys were talking about. Okay, a strong positive correlation. Does that mean the people agreed or disagreed on their music rankings? Agree or disagreed on their music rankings? Agreed. Means they agreed, right? So if this is my axes, not I need an R, don't I? Thank you, Jamar. About right now. Yeah. Well, last hour we had an argument over whether there's one L or two L's. They thought the worksheet was wrong, so we need to look it up. All right. So if this just isn't music rankings, if this is like ice cream consumption and temperatures, right? As X is my temperatures, as the temperatures go up, what's going to happen to the ice cream consumption? Up. So the scatterplot cannot talk today. My goodness, they've got a long break or something. All right. So the scatterplot might look something like that, right? Right? You guys see that? Kind of looks like it's a straight line. But they don't all just fall in a line. They kind of... We can have a strong correlation without having an exact straight line. But I do see the line there. Right? You guys see, kind of see the line there? So, if this were music rankings, this occurred when the ranks tended to be similar. Right? But if this is something else, like ice cream and temperature, this occurs as X increases. What happens to Y? Y increases. And if they have a perfect relationship, the dots form what? A straight line. What do you think this R value is right here? What's the correlation coefficient for this one? 1. Okay. What do you think this one is? 1. Nope. 0.9? It's hard to predict just by looking. We have to use that equation we used last time. Okay. But this one is probably somewhere between 0.5 and 1. Okay. So like on our our hot sauce chart right here, right? It's somewhere in here. Okay. Does that make sense? Now, when we're talking about positive correlation, this only occurs when the X and the Y values are exactly the same. That's only occurs then. And I guess I shouldn't say exactly the same. There could also be like a constant ratio. So like instead of like being 1, 1, 2, 2, 3, 3, it could be like 1, 3, 2, 4, 3, 5. Okay, they always keep going up at the same rate. Right? So that's one example of per positive might look like. Basically, the variables increase with a constant ratio. Oops. No end in ratio. What would that constant ratio be called? I'm going to take a guess. The variables increase in a constant ratio. What would that be called? Slope. Perfect. That constant ratio right there, that is the slope. Okay? It'd be the rise over the run. I have to go from one point to the next. Now, if I look at two consecutive points here, is there a constant slope here? Nope. No, you don't know which point. If I'm here, which point's next? You can't tell, can you? Right? If I'm right here, which one's next? It's obvious. That one. Right? There's a constant rise over run for each point. Right? Whereas here, there isn't a constant rise over run. But this still has a strong positive correlation. This is the best. This is still strong positive. Okay? Does that make sense? Any questions? Okay. The next one is a weak, or not weak, sorry, we'll get to weak in a second. Strong negative. Now think for a moment about two people that disagreed on their music rankings. What did their scatter plot look like? You probably can draw the picture for it right now. You probably know enough about them already to draw the picture. This would be a strong negative correlation. One thing I forgot. I knew I was going to do it because I forgot last hour. What do you know about the slope here? What do you know about the slope here? It's positive, right? If there were a slope to the line, right? Now some of you think, wait, we don't know the line yet. Typically when I give students a scatter plot like this, what do you guys do? This for a science class. What makes you do that scatter plot? You write science next to it? Put in your science folder. What did you do, Jamira?
Draw a line.
Draw a line. You guys want to take a ruler and draw a line of best fit, right? The line of best fit in either one of these cases will have what kind of slope? Positive slope. I did. There you go. Thank you. Don't talk about that R being a little smaller than the rest, okay? It's a little self-conscious. Alright? Doesn't like being the short R. Don't put it out. Alright. So, strong negative correlation. So, in strong positive, the rankings tended to be similar, right? Right? What do you think happens here? Instead of being close, are they close together or are they further apart? Well, they can't be close to them if they're negative, right? If country music was my favorite type of music, and Josh and I have a strong negative correlation, where's country music going to be for him? Is it his favorite or his least favorite? His least favorite. Right? Does that make sense? Right? If rap was my middle choice, where would it be for Josh? His middle choice, right? If classical was my least favorite, where would it be for Josh?
His favorite.
His favorite, right? We would be kind of on the opposite end of the spectrum together. Right? So a strong negative correlation would be, if we're talking about the music rankings again, that means that our ranks are opposite. Yep. Okay. Who? Yeah. Yep. He died a long time ago. Nelson Mandela. All right. So ranks are opposite, right? So if it's that perfect negative relationship, like Josh and I were talking about, my 1 was his 9, right? His 9 was my 1, okay? And all the rest would kind of fall along that line. That'd be a perfect negative correlation. Okay? So what might, let's just say, a strong negative correlation look like? Instead of being a straight line, it'll still kind of have that negative trend to it. You guys see that? So in both these cases, as x increases, what happens to y? Decreases. And if that's the case, what do you guys notice about the slopes? Negative slope. Long, would you say? Why are we learning about this? Because slopes seem to be a prevalent topic. Every unit we've been talking about slopes. You don't need to know about statistics and data analysis? Yeah, what are you going to do when you graduate?
What am I going to do?
Yeah. No idea. Okay. Would it be possible you might go into a field of research or or analysis or science or math?
No.
No? Not likely?
Nope.
Okay. Well, maybe you don't need it. But you'll need it for your freshman year of college if you choose to go there, because you'll take at least one course to deal with this.
Actually,
Okay.
I heard Intellectual doesn't prepare you for college.
Yeah. Depends on who you talk to. Alright. So, negative slope. Does that make sense? No, why not? Make sense? Okay. This one right here is what kind of relationship? What did you say that was?
Negative.
Perfect.
Oh.
Negative. Okay. Correlation. Focus on math here. Okay. Perfect negative correlation, right? That's what that's an example of. Okay. And this one, the ranks for opposite. So for our music ranking example along, it'd be 1 and 9, 2 and 8, 8 and 2, 9 and 1. I think that makes sense. In this case, too, if it's perfect correlation, the variables still change for the constant ratio. And that constant ratio is still a slope, but in this case, instead of being a positive slope, the slope is going to be negative slope. Does that make sense? Is there any question about strong positive correlation or strong negative correlation?
What?
Any question about strong positive or strong negative?
Nope.
No? No, we're not done yet. Okay. Now, if this is r equals -1, then where's this one? What do you think the maximum of this one could be is? Or the minimum, sorry. -1. -1. There you go. So this one, the r value might be between -1 and -0.5. Any questions about strong negative correlation?
Do we have a test on this?
We will have a test on this. Yes. Okay. All right, last grouping is weak or no association, or weak or no correlation. Now, strong positive would be good for predicting what people will agree on music choice, right? Strong negative was good for predicting when people would disagree on their music choice. The weak or no association were those people whose scatterplots looked like what? Were there lines or no lines?
Lines.
No lines. Okay. So it might look like this. So there's their 9 music choices. Is there a general trend there? Is there a positive slope or negative slope? No. There's kind of no general trend going on. Right. So there's no relationship between X and Y, or no relationship between their music rankings. What do you think this R value is? Close to 1, close to -1, close to 0.5, close to -0.5, or close to 0?
0.
Okay. Yeah, this one is close to 0. That'd fall in the no relationship category. The closer you are to 0, the closer you are to no relationship. In this case, the variables seem to be unrelated. Oops, that's not X. Now this one looks kind of like the one above it. Okay. Points are still spread out. But is there a general trend here?
It's negative.
It's got a, kind of a negative general trend. Yes, there's kind of a line going down this way. Right? So this would be an example of a weak association. It would be a weak negative association. Right? This R value would probably be between 0.5 and 0. That's an example of a weak negative association. Now, the variables still seem to be unrelated. Right? But there might be a visible pattern. What'd you say? Okay. Just like a weak negative association, there's also a weak positive association, which you might be able to guess on how it looks. Okay. Take that one out. Okay, so there's a general trend coming this way. They're just dots, right? They're not as spread out as these ones, right? There's kind of a little, I think there's a little upward motion there. No? Now it's hard to just guess at that trend. Right? That's where calculating the correlation coefficient comes in. Right? Like we did on our music data, right? Remember you guys found the differences and squared them and added them all up and went through that, right? You calculate the correlation coefficient. Sometimes it's hard just to predict them, but I think it's easy to predict if we have a weak relationship or if we have a strong relationship, right? That's something I think you can easily do. So this one would be a weak positive association. Does that make sense? Okay. Now in all these weak to no association categories, or in all the ones under the weak to no association, there is a very difficult to recognize or no recognizable trend. Right? It's hard to see a relationship. It's not as easy as if you saw like the strong negative. There's an obvious relationship here. Right? And that's how you can tell if it's strong or weak. If you see an obvious trend to the data, it's probably a strong relationship. If you see kind of a trend, but you kind of have to look or kind of maybe like approximate a little bit, then that's probably a weak relationship. If there's there's no obvious trend, that probably falls in the no relationship category. All right. Are there any questions? Any questions? Anybody?